Okay, so hi, good day everyone. Now, this is example 1. It says write an augmented matrix for the system, then state the dimensions, and we're given y minus 2x equals 1, and the other equation is x plus 3y equals 12. So the first thing that I want to tell you is that this equation, one of them is, but the other equation is not written in standard form. Okay, so standard form, and we can just put this in our note section here, but standard form for a linear equation is anything in the form of ax plus by equals c, where a, b, and c does not equal 0. And a, b, and c are just numbers. Okay, in this case, they're the coefficients, and over here, it's my constant. So that's the first thing. So row 2 here, this will be considered row 2. Row 2 is great. We have something x plus something y equals a number. Perfect. But this first row here, row 1, has an issue. So the first thing that we need to do is rewrite row 1 so that it is in standard form. So y minus 2x can be rewritten, my new row 1. Let's see here, I'm going to say my new row 1. It's going to be, I'm going to flip these around. So y minus 2x can be written as a negative 2x plus y equals 1. And we're not going to do anything to change our second equation, our second row. So x plus 3y equals 12. So that's going to be my same row 2. Okay, so my system went from what we were given here to what we now have below. Okay, so what I want you to notice is that my rows stay the same. I kept row 1 on the top and I kept row 2 on the bottom, and they're both in standard form. So now I can create my augmented matrix from the coefficients and the constant. So this part, you might be like, oh my gosh, this is so easy. Or, man, that was easy. Whatever. You might not get as excited as me, and that's okay. All right, that's perfectly fine. But I take the coefficients here, so I have a negative 2 and a positive 1. And on the other side, my constant, it equals 1. So that's my first row. It's done. Then I have in my second row, the coefficient for x is 1. My coefficient for y is 3. And my coefficient for, my constant is 12. So what we have here, we have row 1, row 2, and then if I turn my hand, this will be considered column 1, column 2, column 3. Okay, so here, this is going to be my augmented matrix, just so that we're clear. This is my augmented matrix, and it's not just a regular matrix because we do have what everything equals. If I only had this and that, yeah, that's a matrix. But over here on the other side with the equal sign, equaling our constants, we call it an augmented matrix. So this is my augmented matrix, and for my augmented matrix, I have 2 rows by 3 columns. So for that reason, I would say that this is a 2 by 3 matrix. Okay, and just like that, you're done. All we're trying to do right now is get you just to recognize the type of matrix. So give me just a second. I'm going to set up example 2 on this same video. Okay, everyone, so I set up example 2. It's the same directions. Write an augmented matrix for the system, then state the dimensions. So we're given 3x minus 4y equals 7 minus 2z. 9x plus 3y equals 3, and 2x plus 4y minus z equals 2. Okay, so just like a minute ago, what I want to point out here is that standard form for a 3-variable equation, linear, is going to be ax plus by plus cz equals d. So we're still going to go in order as far as our variables. So we'll just like an alphabet, x, y, z. So we're still going to go in order. A, b, and c cannot be 0. D needs to be some integer or some number. Not integer necessarily, but some number. Okay, so here we go. So the first thing that I want you to notice here is that we have 3 rows. So here is row 1, row 2, row 3. Okay, now the good thing about this is that row 3, it is in perfect order. We have our AX, we have our BY, we have our CZ, and we know what D is, okay? The issue is that the first row here is kind of out of order, okay? What happened is we are given on our first row 3x minus 4y equals 7 minus 2z. Now, what's wrong here? What is wrong with what you see? What you're seeing has an issue because this 2z does not belong over here. All we need over here is just a number. So we're going to eliminate that and bring the z to the other side. So the only way to do that is going to be to add 2z on both sides. Okay, now 2z does not have any like terms on the left hand side, and so for that reason we're just going to write everything down. So we have 3x minus 4y plus 2z equals 7. Now this is going to be my new row 1. Okay, then the other thing is row 2 has an issue too because we have x, we have y, but we don't have z. Okay, and it equals 3. So what we need to do here is a little bit of finessing, I guess, for lack of a better word. You have 9x plus 3y. Excuse me, good folks, y'all heard my phone ring. So 9x plus 3y equals 3. And so what you can see here is that we know what the a is, we know what b is. We don't have something that represents z. Okay, and we know that d is in the same place as 3. So here's what I'm going to do. I'm going to get a little bit creative. 9x plus 3y plus something is going to equal 3 because I need a placeholder. Okay, so what I'm going to do is what was on that vocabulary. Sometimes you may have to use a 0 as a placeholder. So this is going to be my new row 2. Okay, so now I'm going to put everything together. Give me just a second to set everything up. Okay, folks, so here's what we have. We have our new row 1. We have our new row 2. And we have our same old row 3. Okay, so now we can set ourselves up an augmented matrix that represents what we have here. Okay, so here we go. My coefficients are 3, -4, 2, and then a 7. Okay, that's in my first row. Then my second row has a 9, 3, 0 in a place of z, and a 3. Because I can add 0 to anything. Okay, so then my last row here is going to be 2, 4, -1, and a +2. So this right here is representative of our augmented matrix. Okay, so this is our augmented matrix. We know we have 3 rows. Here, if I'm going to be specific, this will be my column 1. column 2, column 3, column 4. So in this case, we have three rows and 4 columns. So this augmented matrix is a 3 by 4 matrix. Okay, so as always, if you have any questions, don't hesitate to ask. I am available. The coaches, Coach Jack and Coach Williams, is available for you. Don't sit there if you don't understand. Just say something. Okay, it could be a small, very, very small misunderstanding, and we are here to help you and support you. Okay, so this is example 2, and you're going to have some practice over the same thing. Okay, so all the best to you with your practice.